Well, greetings everyone, and welcome back to the Bass Blaster Audio Deck YouTube channel. And in this video, we have a very shiny desk. No, I'm kidding. I actually have something that is not in any way remotely close to audio, but I thought I'd post it anyway. Let me try to grab it and swing it over here. This is the base to a dimmable lamp up in the living room. It's a dimmable lamp. Then the issue is it no longer dims, it's stuck at full brightness, and the knob is extremely hard to turn. So I've already done the fun part of getting our circuit out. I'm going to set this shaft on the ground. I'm going to cut this zip tie. Let's try to snip that. Maybe I can keep this thing on the shaft on the floor. This is a dimmer switch, as I said. You turn it on and then you can adjust your brightness. The only problem is listen to that turn off. It's real hard to turn off and it's stuck at full brightness. So what the issue is, I'm not entirely sure. Our power switch is obviously knackered. I don't know if that's the reason for it no longer dimming, or the triac could be no good. So let's cut into our box here. It's just taped around. And this is exactly what I thought. Let's get a closer look at this, why don't we? Alright, so we have a funky looking knob. I'm not entirely sure how this works, but we got two contacts here, and then two bigger ones up here. We have a capacitor, 250 volt. We have a diac. I've never seen a diac before. Then we have our heatsink, which is connected to a BT136 triac. Let's whip up the datasheet for that. Alright, here it is, BT136. Let's just do some general looking here. RMS on state of only 4 amps. That's actually a pretty small triac. Most of these things are like 12 amps or greater. Non-repetitive, 25 amps. Alright, so pretty boring. Alright, so what I'm going to do is I'm going to turn the iron on. And there's also one part on this board I missed. This is a 3.3K resistor right underneath this funky potentiometer. So what I'm going to do is I'm going to desolder this pot. Check out the solder joints. Solder joints don't look too bad, but I'll probably touch them up anyway. And we're going to dismantle this and see if it can be fixed. Kind of like rebuilding it. See, I'm looking. I see the wiper on the top is turning, however, I'm not seeing anything on the bottom. I gotta have the knob to shut it off because it's that stiff. Not sure. Put on the iron to heat up and then we'll pull this thing off and see if we can get it dismantled. Alright, so the iron's warmed up. Try to straighten this wire a little bit so it'll kind of sit mostly on its own. I'm just going to use the my $9 solder sucker pump thing that doesn't really work. Alright. I can get the rest of that with some braid, probably. I'm turning my temperature up. Alright, here it is. I've never seen anything quite like this before. Right, so I'm pretty sure how this works is these two leads here is your normal potentiometer. And this one down here is your AC main switch, and I get that by looking at the board layout. Yeah, yep. Alright. So this says B504. That's, what is that, like 500K? Let's test that and see if it's still good. Try to prop that up on something. Okay, this ain't working. If probes don't work, stick alligator clips on it. Alright, it's all the way down. We're sitting at about 18K. So we turn it up. So all the way up. Yep, this is a 500K potentiometer. Now this bottom one will be our main switch. So maybe the triac is the issue. Okay, our main switch is on, about 0.5 ohms. A little dirty, could use some contact cleaner. And now, shut off, it's open. Yes, I think our triac is the issue. This knob is working exactly as it should. Could also be that capacitor, could be that resistor. Matter of fact, why don't we just check the resistor now? Alright, so this is a 3.3 k ohm resistor. 3.31. A diac. I have no idea. How do you test a diac? Okay, I just did a Google search on how to test a triac, and I didn't find a straightforward answer without having to build a whole AC circuit. But diacs are used to help trigger circuits when a triac is used, which that's what this is. I might just replace every part on this board. Give me a minute. I'm going to look at this capacitor and this diac and let's see what I can find over at Mauser. Over to the bench onto Mauser. For triacs, the BT136, we have a Rectron brand, then we have a bunch of Chinese brands. So apparently I can't get the BT136 in a good brand like On Semiconductor or ST Microelectronics. But it's about 60 cents. The diac that's on the board is a DB3 C412. Well, DB3 is all we need. ST Microelectronics, it's a 32 volt trigger. This one's 48 cents, this one's 39. Looks like the difference is the breakover current. So I searched the datasheet for the C412 DB3 and let's see what this gets. Molex Electronics, really? It's actually a name brand component? I don't believe this is correct. So whatever, I guess we'll just go with this one then. Okay. Now, what about that capacitor? I'm going to spray a little bit of deoxys into the switch. Maybe it's just dirty, which is why it turns so hard. Try to just get a little bit in here, and a bug just flew into my window. Oh wow. I could blow on that and it'd turn now. Yeah, switch was just a little dirty. Alright. Ooh, deoxide oil. Alright, so I've done some Googling, and I found a site showing a schematic of how you can test a triac. So what I'm going to do is, we're going to remove it. And then we're going to breadboard up the little test circuit, see if this triac is functional or not. This solder pump sucks. I think we actually got it. Wow, I ain't done that in a while. I'm going to get this bolt off. Where's my pliers? Sitting on top of a speaker, that's a good place for them. Screwdrivers. Now, there's no thermal paste on that triac at all whatsoever. Nothing. completely dry. Pull out a breadboard and assemble our little test circuit. Put this nut back on the screw and I'll stick it through the heatsink, or else it'll be lost, never to be found again. Actually, no, this just saved me time. I don't even need to build the circuit, because if we test our triac, right, so the pin on the right is our gate. That's pretty much what turns the thing on and off, considered it's labeled gate on the board. This is the BT136 600E, which is the exact same one I found on Mauser. If we go between our two AC input pins on 200 ohm range, complete short, flip our leads, complete short. Is it, you think it might have overheated? These triacs don't put off a lot of heat, but it was secured tightly. Oh well. Regardless, that is our issue. Our triac is kaplooey. Alright, it's about a week later. Mauser parts finally came in. Got a new triac. This has the NXP semiconductor logo on it. Capacitor. And a triac. The rest of this is just some random potentiometers and some LEDs that I wanted. So, as always, we're going to get the iron warmed up. Pull the dimmer circuit back up here. And get these new parts installed. Here I've got the knob and the heatsink with the shorted triac. I kept it bolted on just so I didn't lose it. I guess while I'm waiting for that, I could take them out of the things, right? Let's try to get our triac out of here. Just pop this out. And get a new triac. Just throw that away. Diac, which I probably didn't need. And of course the capacitor, which I also probably didn't need. However, it's a capacitor across an AC line, so I'd rather be safe. Alright. I'm going to stick this in the tester just to see how close it is. This is a .039. Pretty close. Test is .037 microfarads. Good enough. This new diac is an ST Micro brand, so only the best. No, iron's not quite hot enough, but whatever. That works. C823. No, 823. Okay, yeah, that's... I don't know where the other 820 parts went. Let me go ahead and reattach our funky knob. Okay. Get our new capacitor. Oh, fits perfectly in there. It's the exact same footprint as the old one. Ouch! Jesus Christ, that was hot. If I get just enough to tack it on there, which I can't, of course. Maybe I can do this. Ow! Board's still hot. There we go. I'm just going to pop out that diac, which is that one. Ooh, iron's nice and hot now. There we go. Just fell right out. Diac, of course, does not have a polarity. keep those leads. These are good leads. These are probably tin-plated copper. Alright, and now we just need to get the old triac off. Stick the new one on. It's currently storming outside. I'm gonna put some thermal goop on this. This stuff's kind of tricky because it turns to oil and you gotta mix it together a little. Set that there. Alright. Okay. And you put the nut and bolt through it to bend the leads. But then I gotta take it off because the bolt goes through the board. I didn't think that through. Where does it need bent at? Oh, okay. Right at the bottom. Ugh. This thermal paste is getting everywhere. There we go. That ain't never coming off. Now I just need to solder the triac down and this will be done. Ugh. Try not to get any more thermal goop. Heatsink's probably nice and warm now. Working on it. So I gotta make sure I put this piece of cardboard back on because, well, there's no insulation between the triac and this heatsink. So, this heatsink has AC on it. Oh, it has live AC. Looking at the trace. So this would be the same as you stuck the finger in a wall lit. And there we go. New triac, capacitor, diac. Now to get its little cardboard sleeve wrapped around it, it'll be all done. Okay, so made by a brand called Zing Ear for halogen or incandescent use only. 500 watt max. Well, yeah, that's all the triac could be good for. 120 volts at 4 amps. Oh, what? I gotta take this nut and washer off this potentiometer. I also left it on there so I didn't lose it. Now it fits on there properly. I do not have any tape in here. Oh. There we go. Make sure you're all mushed together. Alright, so to test that the triac works before I actually take it upstairs, I'm just going to shove a voltmeter into the output and plug the other end into the wall. Oh, that's nice, my probes don't fit in the thing. That makes this a little more difficult. Alright, let's try this. So I have it off. I'm gonna watch myself here. Is that visible? Not really. Alright, so I'm going to turn it on to low. See what my voltage is. 47, let's turn it about halfway. 56, up a little more. 65, up a little more. 83, and all the way up. We have 94, really? It might go up when it's under a load though. Alright, now I need to try to get this reinstalled into its tube, which is a whole job within itself. Okay, the image is a little overexposed, but it's darker here. How you get this back into its tube is you gotta feed your wire into the tube, which the best way would be just to pull it from the bottom where it comes in at. Okay. Take your knob off. Get rid of wire slack. Now we need to fish this so our knob comes out of this hole. Now we put our washer on. Our nut. I'm not doing a very good job showing this. It's better. Okay. I'm sticking my finger in the tube to make sure it's sticking all the way out. Get a pair of pliers and tighten it, but don't do it too tight because the threads on the pot are plastic. Now we'll stick our knob on. I'm just going to make it so off is pointing straight down. And there we go. Our dimmer is back installed. Okay. Now I need to take this upstairs. There we go.